Okie dokie, Lancers. Here we go with 12.4, part 2 of part 2. Okay, so this one's a little bit different, right? It kind of looks the same at the start, where you see here we have the angle formed by two chords in the middle of the circle somewhere, and then we have two secants forming some type of uh, angle out here, and same thing here. However, this one is completely different than the previous section because we are no longer talking about how these intercepted arcs relate to one another and the angle, right? The designated angle. Instead, we are simply talking about how do the length of these chords or the segments created by these chords, or the vice versa, relate to one another. All right, so this is all in terms of measurement now, not in terms of arc length or angle measurement. Okie doke. So this is all length of the line or the chord or the secant or the tangent, however you want to call it. Okay, so in this theorem, take a look, right? In this section or case 1 here, what we have is so simple, right? We're going to take the length of A and the length of B, right? Again, those lengths are created by that intersection there. And that is, we're going to multiply those, and they are simply going to be the same as if we were going to take the other chord now and split that up into its two components. Okay, so there's case number 1. Case number 2, what we're going to do here is this one gets a little tricky here, but notice it says W, right? We're going to add those guys together. So basically we're going to get the length of this entire arc. I'm sorry, what do we call that? Secant, right? And we're going to multiply it by the little guy on the outside, W. All right, so same thing on the other side. We're going to get the length of that entire secant. That's why we have a plus sign there. And then we're going to multiply that by the length of the little guy over there. All right, and then lastly, with case number 3, it actually relates to this guy, and I'll show you in just a second. So notice what we're going to do here. Let's start with the left side, right? So we're going to add these two together, multiply it by the length of that little guy on the outside. And actually, that is the same thing that's happening there, except it's just two tangents, right? But think about it. If my tangent were to start out here, and I drew it like that, right? So that's not a tangent, that's a secant. And eventually what ends up happening is that this guy, so I'm going to try to do this here on the spot, this guy here, right? There it is. If I keep moving him up, eventually the part in the inside becomes 0, right? So this is actually that T. Actually, let me just draw that down here. That T is actually kind of like a 0 plus T and then a T on the outside. And not that squared. So if you get that, awesome. If you don't worry too much about it. We could talk about it more later. T basically is the variable that they're using for tangent. All right, so if you see a tangent, then basically you're just going to say tangent squared. All right, so again, case 1, case 2, case 1, case 2, case 3, theorem, blah, blah, right? We just don't even want to talk about those. End of the year, we're trying to bring it on home here. All right, so take a look at what we got going on. And if I left the solutions on here for you, why not? Let's just take them off. Let's just pretend it's class time here, huh? So boom, 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 and boom, boom, boom. Right, I'll do those with you guys right here. So take a look at the problem. What we got is from case number 2, I believe, right? So we have this secant that goes out here, this secant that goes out here. Remember, we're going to get the sums of these two, the sums of those, and then we're going to multiply by the little guy out there. So let's see what we got, right? We're going to say 6 plus 8 times 6 equals, and then y plus 7 times 7, okay? They're really nice to us because that y is on the inside and not on the outside. But for you honors people, maybe we can figure that one out for you one day. Okay, so let's take that, right? This 6 plus 8 is 14 times 6. That's going to be, so this whole thing, that's going to be 84. All right, we're going to distribute that 7 out there. So 7y plus 49. Bring that 49 over, subtract it by into both sides. Boom, okay. So now we're left with 7y. 35 and y equals 5. So there you go, right? Not so bad. In this case here, notice that's a tangent. So what we're going to do, again, we're going to get the length of that entire guy and multiply it by the outside. So 16 plus 8 times 8. And then let's say z squared. Okie doke. So let's see what we got. Simplify that together. That's 192. Right, z squared. It shouldn't be an issue here. Just make sure, right, you see that squared. And then we're going to get the square root of each side. So z is going to equal approximately 13.9. All right. Shall we try one more? Sure, why not, right? So take a look at b. We haven't done b yet. But remember, this is on the outside. So all we are going to do is we're going to say 3 times 7 equals, oh, I'm sorry, I kind of looked at that the wrong way. 3, I think that was right. 3 times 7 equals m times 6.5. Yeah, sorry about that. And then we're going to divide each side by 6.5. Boom. Boom, right? So m equals 21 divided by 6.5. So 3.23. There you go. All right, take a look. And here we are. We are at time to do practice problems. All right, guys, way to hang in there, and I will see you at the next class. Good luck.